Welcome to the deep dive and welcome to our YouTube channel. Today we're jumping into, well, pretty much the biggest topic there is, the very beginning of our universe.
That's right. We're looking at the Big Bang, pulling insights from a really clear video, The Big Bang Explained, without the jargon. It's from the channel Cosmology Unveiled, The Big Bang and Beyond.
Yeah, great
Our
channel.
goal here is to, make sense of how everything started. We want to pull out the key ideas and clear up some common mix-ups people have about it.
Definitely. Making these huge concepts feel a bit more, well, understandable. It's all about that aha.
Moment.
Right.
Exactly. That joy of discovery.
Okay, so let's get into it. The Big Bang. Most people, I think, imagine this huge explosion like cosmic fireworks.
Yeah, that's the popular image, but the video is really clear. That's not quite it. It wasn't an explosion in space.
Right. That's a big shift in thinking.
It really is. The Big Bang Theory describes the beginning of, well, everything. Space and time. They both started then.
So space itself popped into existence and started stretching from something incredibly hot and dense.
Precisely. Not something blowing up into an already existing void. Space itself expanded. That's fundamental.
Okay, but if space expanded, where did it expand from? Like, where's the center point? That's always puzzled me.
That's a super common question. The video uses a great analogy for this.
Ah, the balloon one.
Yeah, the balloon. Imagine drawing dots on a balloon surface. As you blow it up, every dot moves away from every other dot, right? But there's no single center on the surface of the balloon. And the surface isn't expanding into anything outside itself.
Ah, okay, so the universe is the expanding balloon surface in that analogy.
Yeah.
There's no outside it's expanding into and no central starting point on it.
Exactly. It helps visualize how everything can move away from everything else without a specific center. A bit mind-bending, I
It
know.
really is. But it's not just a neat idea, is it? There's solid evidence. What does the video highlight as the main truths?
Oh, absolutely. The evidence is strong. First up, there's the cosmic microwave background, the CMB.
The universe's baby picture, sort of.
That's a perfect way to put it. It's this faint leftover heat, a glow from that very early, hot, dense state, and it's everywhere, like an echo.
Wow. So we're literally seeing the remnants of the beginning.
We are. Then there's redshift and Hubble's law. You know how a siren sounds lower pitched as it moves away?
Yeah, the Doppler effect.
Kind of like that, but with light. As galaxies move away from us, the light waves they emit get stretched. Longer wavelength means redder light redshift.
And the further away, the faster they move, the redder the light.
You got it. That's Hubble's law. It shows the universe is expanding. And third, there's the amount of hydrogen and helium we see.
The basic elements.
Exactly. The Big Bang model predicts exactly how much of these should have been forged in those first few minutes, and the amounts we observe match those predictions perfectly. It's like a chemical fingerprint from the start.
Okay, CMB, redshift, element ratios. That's pretty compelling stuff. Yet people still get tripped up, right? What are the big misconceptions the video tackles?
Yeah, definitely. Well, number one, as we said, it wasn't an explosion in space. People still picture that.
Right.
And number two, thinking it's expanding into some empty void. Again, space itself is what's growing.
So there's no outside for it to expand into.
Correct. And another big one is the idea it came from nothing. That word nothing is tricky here. It might not mean nothing in the way we usually think.
Which leads us right into the really deep end, doesn't it? Like what was before the Big Bang, if time itself started then?
That's where we hit the edge of current knowledge. The video mentions this too. It's a huge open question.
So things like the multiverse or quantum foam, that's still speculative.
Very much so. Fascinating ideas scientists are exploring. Maybe our universe is one of many. Maybe space-time itself fluctuates at tiny scales. But yeah, we're still figuring that out, grappling with the fundamentals.
But what we do know, based on the evidence, is that this expansion didn't just happen and stop. It's still going on now.
Absolutely. The universe is still expanding, and because of that expansion, it's actually getting colder over time. Galaxies are getting further and further apart.
And it's not just expanding, it's speeding up.
Yeah, that was a major discovery. The expansion is accelerating. And the cause seems to be this mysterious thing we've labeled dark energy.
Another huge cosmic mystery.
It really is. It seems to make up most of the energy in the universe, pushing everything apart faster and faster.
Okay, let's recap then. The Big Bang. Not an explosion in space, but the start of space and time itself, expanding from a super hot, dense state.
Supported by key evidence like the CMB, that background glow, and the redshift of distant galaxies, plus the hydrogen-helium ratios.
And it's still expanding today, even accelerating, driven by this dark energy stuff.
Exactly. And understanding all this, even with the remaining mysteries, it really changes how you see, well, everything, our place in this vast, evolving cosmos.
It definitely puts things in perspective. It's incredible what we've been able to piece